If you watched my first video, then you'll recall that I decided to build an OPA Alice microphone for $100 to compete with brands from Sennheiser, Sony, AKG, and Neumann, because I felt that microphones had gotten way too expensive for the value proposition that they were providing, and I felt that as a DIY audiophile, audio enthusiast, audio person enjoyer, I felt that I could do a better job for $100, and that led me through an entire month of research looking at microphone parts, how to build a microphone, what RF signal capacitors are, and a bunch of other research that's not relevant because you can watch it all in this video right here, actually right here, right somewhere. But basically I decided to build a microphone, and unfortunately something about the soldering process went wrong and the microphone didn't sound well. Now, using a donor body, I felt that I had probably messed up something with the wiring. There could have been any sort of interference coming from the body of the microphone, but I was completely in over my head on what to do. But a lot of you were really helpful in the comment sections, especially with buying better tools, choosing solder, choosing cables, choosing to use flux or not to use flux, and basically had a lot of advice. Now, unfortunately, by the time I read those comments, I had decided to make a video going on Amazon and ordering whatever Amazon told me to order. But I did end up getting a relatively good, cheap, and affordable, during Black Friday, of course, soldering kit. Came with solder, came with a stupid wet sponge, which we'll get into later, and came with a soldering iron that could handle basically all my soldering needs. And then I decided that I was going to do a car video instead, and that video was very helpful, and it was a video that I wanted to make, and some of you watched it, some of you didn't watch it, but we're going back to DIY. And so what I wanted to do was I wanted to fix my mistakes with the microphone and get it working. And in order to do that, that required me to do a bit of research. Almost as if they saw me coming, OPA decided to publish a guide on how to troubleshoot your microphone, and this guide was invaluable. It goes over the principles of troubleshooting, understanding what makes a microphone tick, and where you probably would have gone wrong. Now see, the main issue I was having was static and noise that was so bad that you were basically unable to hear my voice because most of it was taken over by high frequency static. Now I realized that when I wiggled the black cable, this is what was causing the issue, and so I decided that the best thing to do was to go ahead and fix that black cable and see if I could do something about it. Now, fortunately for me, after reading this guide, it kind of put a lot of things into perspective. I was able to move forward with this sort of confidence, this aura in a way that made it easy for me to understand how I wanted to go about doing this. But the issue was that I'm not good at soldering. I've actually never soldered anything before. That was the first project where I actually really had to solder things. And if you are anything like me and you have clumsy hands or like just bad balance in general, this isn't a job for you, especially if you have hands that are just huge and you're trying to fiddle with small components. But with the tools that I bought, I felt that it was time for me to at least give it another try. So I did. The long way. And so I decided the best thing to do was to grab the solder sucker, grab the iron, and go straight to the old soldering joints and just completely remove them. They were garbage anyways, and quite frankly I think that they didn't really help when getting the cables in there. I did have a bit of trouble, but in the end I was able to do it. Okay guys, so as you can see, I cleaned up the soldering quite a bit. I laid down some new solder. It was a lot easier, I can tell you that much. It's really hard for my camera to focus. But I laid down some solder right here, so we now have better soldered wires and connections. That black wire that had a lot of play and give before should be a lot better now. The red wires aren't perfect, the top ones aren't perfect, but you know what, I'm going to test the microphone out and see how it works. Yeah, spoiler alert, it failed miserably, but I had to double down and completely reapproach how I was doing this, so I decided to go back at it again. I picked up a wire stripper from Amazon for $8, some capacitors that I needed for any RF signal interference to get rid of any issues with the XLR inputs, and then some cheap bendy cables that I got off of Amazon. Didn't really know the gauge, but it was cheap, so I bought it. The first thing I got to do was working on the XLR input by taking the 22 nanofarad capacitors and soldering it to it, and then using a piece of solder as a bridge between the XLR input number 3 and the ground. Now this wasn't particularly too hard to do, but I found that it was taking me a lot longer to get those long stems to stick in there properly, which created some problems when I was trying to get the cables in, but it ended up working after all. Now the next thing I want to do is take a look at the OPA board and start to clean up some of the old wiring I did, because quite frankly it's garbage. Now the next thing I had to do was to clean that up by adding some new soldering and some new cables. Once again, I highly recommend getting stiffer cables, but so far the soldering job wasn't that bad, but I think it could have been better. Now the next big thing was cleaning up the old solder, and that ended up taking me, I don't know, somewhere between 1 and 4 hours to get done, but afterwards I was able to clean it up, and that made routing the wires through a lot easier. As you can see here, the soldering job was absolutely abysmal, but I did end up getting it done in the end. Then took the cables and routed it directly to the capsule, but as you can see here, we now have a fully completed microphone with color coded wires, which is going to make diagnosing this easier later on should any issues arrive. Quite frankly, I think the soldering job I did was a lot better than the first one, but overall I wouldn't say that's the best, but it did take me a couple of hours, but eventually I did get it done, and I'm relatively proud of my results. And overall, despite it taking 4 hours and me having what is inarguably the worst shooting day of my life, I mean, I forgot my SD card, I forgot my camera mounts, I forgot everything, I would say that the soldering process went relatively easy. I came home, I grabbed a microphone, I plugged it in, and it worked. And I find it to be absolutely amazing that it worked, because honestly I thought my soldering job was kinda crap. I mean, take a look at the soldering job. This job is terrible. Like, this job is god awful. Like, these joints are bad, but it worked. And that's the most important thing about it, was that despite me not getting it right the first time, I still was able to go back and try. And what this proves was that I could build a microphone that sounded good. So a lot of you are probably like, well, okay, this microphone that you've been holding this whole time isn't your microphone. Where is the microphone? And I'm glad you asked. And this is the microphone. It's really small, lightweight, everything I mentioned before, but it's actually finally fixed. Now, the thing about it is that I haven't been using this microphone for this last week. I sent it off to one of my friends who's a music major to do some recording, do some vocal tracking, and see how it went, and he gave it a 6.8 out of 10, which is totally fine by me because we spent $68-ish on components. So that's realistically not that bad, and as a person who spent time in a professional recording studio, I'll take it. The good thing about this microphone is that it's really cheap, but I would say if there's one thing I could change is do not cheap out on this body. It's light, it gets paint scratches and chips really easily, the paint isn't the best, and I think that overall there's a bit of interference when you tap on it that actually makes the capsule start to vibrate and it makes noise. Something that's made out of brass or something that's heavier will not have these same vibrations, so I would say that if you're going to make a microphone similar to this, please do invest in a better body, and I will most likely take the components out of this body and put them in a different microphone body, but because I wanted it to be light, cheap, affordable, and easy to replicate, I just went with this body, even though I think quite frankly it's a bit too small for my liking. But as a proof of concept, as a basis in which other projects could be based on, I could not be happier with this microphone. And I could not be happier that you, the audience member, you watching right there, yes, you at home, stuck along this long into the video to watch me talk about this microphone. I think that it's a good product. The assembly was a little bit hard, but I felt like there's a lot that I learned from here. You know, the thing about engineering and product design is that it's really hard to come up with a good name that's easy to remember. We have things like the U87 and the AKG 2020 and things like that that are made by reputable brands that everybody knows in this space, but I think if you're going to create a product, you should give it a name. And while this one is a prototype, I think that this should also have a name. So I'm going to call it the RW01P. Real simple, not Sony-like in any way, shape, or form. And you're probably like, what does that mean? And it's short for the Ray's World 01, as in the first project on this channel, P as in prototype. I appreciate any and all comments, improvements, suggestions you have on this microphone. This is what I've set out to make this channel for, is to do projects like this that are really research heavy. I'm sorry it took so long to get this video out. It did take some time getting this tested and making sure that it's good. And I will now play some audio clips from the microphone recording so that you have a comparison. And this is what the new microphone sounds like. I actually had to turn the gain down because the original microphone that I was using is really power hungry and I couldn't get enough power to it, so it was really loud. So instead, this is what the new microphone sounds like. It's a lot lighter, easier to hold. It's designed to be placed in like a bedroom studio, and I'm really happy with the quality, and I'm hoping that you are too. If you guys enjoyed this video, make sure to leave a like and a comment. Tell me what you want to see next. This is definitely one of the biggest projects I've done in a very long time. Learning how to solder, designing, months of research, putting it all together. I'm sorry for the delays. We'll return back to our regular schedule as time goes on. If you guys really did enjoy this video, I would really appreciate it if you let me know what you want to see me do next. I've been Ray. This has been my channel, and this has been me fixing the $100,000 microphone. And this was me fixing my $100 microphone, which I will now be using forever for the rest of the channel. Hope you guys enjoy the rest of your day. I'll see you guys later.